Hi there, and welcome back to part 9 of our tutorial series on creating the classic game Pong in Unity in 2D. Today we'll clean up our project a little bit, something that is probably often overlooked, but I think is an important part of game development to do at the end of a small project or often in between when working on larger projects. So that you can really continue working on this project and it is in a clean state. Or if you finished a small project and want to develop it further later down the line, you will be happy that you did this, trust me. And we also learned some new things along the way, like inspector attributes and conditional compilation. If this is the first video of this series that you're watching, I highly suggest starting at part 1 of the series. I have a link to the playlist in the description because these parts are building on top of each other. But if you just want to check out this part on its own, you can do so. We have a link to the GitHub repository also in the description, and the GitHub repository has tags after each video, so you can check out exactly the state of the repo after each video. So let's do some cleaning, shall we? I think the hierarchy already looks pretty good. One thing I want to do is make the ball into a prefab. And we only have this one ball yet, but we might decide to have multiple balls in the future, and it's good to have a prefab for that, just in case. And by the way, I just noticed this while trying things out. Don't try to undo making something into a prefab. Control Z. If I press Control Z, the editor is gonna crash. If you want to undo this prefab move, you can go on the ball, right click, prefab, and unpack or unpack completely. And this is gonna remove the prefab connection. And then if we delete this prefab here, it's like it was before. But once again, we want to make this into a prefab, so let's do that. So I'd highly suggest turning everything into a prefab that you use multiple times throughout your project. And it can also make sense to turn something into a prefab that is only used once, because there is an added benefit to this, because the prefab can be edited independent of the scene. So if you're working in a team and you're using version control, one person on your team can work on the prefab while the other person can work on the scene, and thus you can have a more parallel workflow. I would like to show you one more way to organize your scene. Of course, there are multiple ways. I like the way with nested parents and children objects, but some people like it more like this. Check this out. So you have these empty game objects that just say, okay, next up, there's gonna be UI stuff. So canvas and event system belongs to UI. Or maybe we can make this level into such an empty game object. Empty game objects, you can just have them in there. They do nothing unless you have millions of them. Then there's probably gonna be a little performance hit, but that's not the case in our game. And we can move these out of here and below the level. So some people like to organize their hierarchy like this. It's a preference. Like, I like it if it's nested, so I'm gonna undo all of this, but you can try out what works best for you. And yeah, maybe move this canvas and event system under a empty game object called UI. Next up is the project view over here, where we have all our assets. And since we don't have a lot of assets, this is also pretty clean already. So we just got this one little physics material bouncing out of any folder. So it's not in any folder, and I never know where to put these physics materials in my own projects. So it has material, but it's actually not a visual material. So sometimes I put them under materials in a physics folder. So let's do that here. It's actually not really correct, because this materials folder is under art, and this physics material has not much to do with art. So maybe you could also create a new top level folder called config or something for this. Yeah, just how you like it. One more thing is the scripts folder, because this one is already quite big. So let's create a few subfolders to have a better overview. And what I like to do in most of my projects is using like 3 subfolders called game, player, and 1 second, world. So I think this is a good distinguishing between the different parts of the game. So for the game we have the UI, the manager and the audio, so we can just select it and drag and drop it over here. For the player actually only controls the pedal. So we only move the pedal in here, and usually like one subfolder for one script is usually not that great, but you can do it totally. But in usual games, there are many more scripts to handle player interaction and player animation and stuff like that. And all the other things except shake goes into the world. And for something like our screen shake, I like to create, it does recompile really quickly, a folder called util for utilities. So that's what this one is. So let's move it in there. Now, in bigger games, there can be many more subfolders like these. For example, for data, cameras, UI, and so on. For our game, it looks pretty good now. But once again, if you make a bigger game, try to keep things tidy here and clean by using subfolders. For example, you can have subfolders for certain types of objects. We could have like subfolders for in the world, for example, for our ball, a subfolder, something like that, or for different levels if you have them. And this isn't only true for our scripts folder. The other folders can get out of hand quickly too if you have a lot of content in your game. So try just to tidy things up every now and then. So if you open the folder and see like, whoa, there's so much in there, I don't have an overview anymore, take a few minutes, create some subfolders and tidy things up nicely. Next up, let's look at some code stuff. And for this, let's check out the inspector for our ball first. So here we have our ball script, and it has a lot of variables already that we defined ourselves and that we can assign and adjust in the inspector. But imagine this being 2 or 3 times more variables. It gets confusing quite easily, but there's a remedy for that. And it is called inspector attributes. So let's jump into the ball script, and don't be surprised, I'm gonna paste something here and I'm gonna explain it right now. So we got these square brackets here that is just above a variable, and they do something in the inspector. So for example, the header attribute adds a little header. We're gonna see this live in action in the editor in a moment. And we can have an editor called refs for references. These are all our references. And then we can have a header for our config. Maybe make this a little bit more clear by inserting a line break here. Okay, gonna see this in a second. Then we have the range attribute. This is for numbers, and it gives us this little slider in the inspector where we can adjust a value between a minimum and a maximum. Then we have the tooltip. It's a tooltip. If we hover over a variable's name in the inspector, then it's going to show us this tooltip. This is super great for communicating with your team what a variable does without them needing to go into the code. Maybe some of them are not coders and they just want to know what this variable does, especially game designers. And then also we have the space here. This just creates a little space. So let's check it out. And it's going to compile real quickly, and we're going to see it live in the inspector. Right here we have our little header, refs, and this already looks much better. And here we have our config header. Here we have our little slider, aka range attribute. And I'm going to reset this real quick to the prefab value. Yeah, and here we have this little space right here. So with inspector attributes, you can make your inspectors much nicer to look at and work with. Oh, and of course, we also have our tooltip. So if we hover over this one that we tooltipped, it's gonna pop up like just a regular tooltip. That's really nice. Let's have a look at so-called hard-coded values next. And for this, let's jump into the pedal script. And let's move down a little bit. So hard-coded values are values where you put like numbers directly in the code, where you cannot adjust them, and each time you have to change them in code and recompile to test out some different configuration. And it's a much better practice to have most of these as adjustable variables. And by the way, you can also define variables of the same type after each other in one line by just separating them with a comma. So we're gonna get this AI move speed multiplier minimum and we'll set the maximum. Okay, and we're gonna feed this into here. So the minimum first and then the maximum. And now if we head back into the editor, they're gonna show up in the inspector and we can adjust them without going into code, and we can also adjust them during play mode, which is great. So I just added a little header in here for the AI variables to make it look nicer. But what I want to encourage you to do is check out these places where you have hard-coded variables and make them public adjustable variables so you can play around with them and improve the feel of the game. So let's look through the pedal and the ball script, for example, really quickly to see if we have still some left in there. So for example, ID 1 and 2, these we don't want to change because they are really identifying our left and right player. And here in this line we have the direction. This is also something that we don't want to change because 1 and -1, they are directions, they say left and right. So we don't want to change this. We could make this value here adjustable, for example, but otherwise this one looks good on that front. And let's move into the ball script and have a look at that, what we can change. So maybe we emit some particles. We can make this an adjustable variable and see which amount of particles feels good, for example. Or we can make the screen shake adjustable variables and see what feels good. So yeah, you get the drill. Just go through the code, see where you can remove these hard-coded variables and make them adjustable so you can play with them in the inspector and get just the right feel for your game. I'm talking about these public variables a lot, but from a software engineering standpoint, this is actually not the best way to go. So I'm just going to quickly show you this. Public, it means these variables are accessible from the outside. They are public. So we got this reference to the ball in our game manager, so every other script could get a reference to the ball from the game manager and actually change the speed multiplier or any other public variable. And yeah, this is a bit of a safety issue. So actually, only the ball is changing the speed multiplier. We can check this by clicking right click and using find all references, and we see only the ball is changing this one. So it's actually a private variable, but one that we want to adjust. We don't want other scripts to adjust it, just the ball itself, but we want to adjust it in the inspector. And you can do that like this. You can make this variable private and you can add the serialize field attribute. So let's head back into the editor and see how this looks. And it doesn't look any different, and we can adjust it here. But now other scripts can't access this variable anymore, and so we are more on the safe side. And we could now change all or almost all our public variables to private float and serialized field. And this is what a lot of people actually do to make their code less vulnerable. Yeah. I think for small games like this and beginners, it doesn't make so much of a difference. This only comes more into play when you're working on bigger projects or with a team where you don't know if your other team members might change your public variables. Maybe this is also a communication issue. So public communicates, hey, this can be changed from the outside, and private communicates, okay, this can only be changed by this class. So this is more of an advanced thing. I just wanted to show you how you can implement this and make your variables secure. Next up is this little method here on the pedal script, is left pedal, and we wanted to replace everywhere where we compare the IDs with this method so it's all in one place. So we can check by right clicking on the ID, we can check find all references and see where this ID is used. So we got it up here in the isAI script. So we can replace this ID equals 1 with our method, and this ID equals 2 also with our method, but negated. Yeah, exclamation mark before it, that means it's negated. And we also got this in this place right here. And this one, these are quite a few lines of code. We can make this so much simpler with using this method and the ternary operator. So let's change the movement to using the ternary operator. We check is left paddle, which is the same as this case 1. And then we give it this input here. And otherwise, we give it the player 2 input here, okay? So this reads movement. If it is the left paddle, then get the input from player 1. Otherwise, get the input from player 2. And we can remove this whole switch statement if we want to. So we can actually also, this equals null. We don't need this. We can also remove this. And actually, we can make this even shorter. We don't even have to declare the variable first. So we can just return this expression right away. And this whole method is just one line of code. Beautiful. I also always want you to think about your variable and method names to make them say exactly what this variable or method does. We got this case here. This method is called process input, but it's not really processing anything. If it's called process input, I would expect that it's changing some variable, but it's just returning the input. So right click on this method name and rename, and I think get input describes much better what this actually does. Also right here in this method, this gives us so much, this method, is a minor performance optimization that we have. So right now we are having these strings in here, and get input, this one is called from the update method, right? So it's called each frame. So each frame we declare a new string, actually 2 new strings to check for this, and these strings, they are generating so-called garbage, and if it gets a lot, this can affect the performance of your game. This is not the case here because this is all still a really simple small game, but I just want to show you what you can do with strings that is kind of better performance-wise. So we can declare these strings as constant strings up here, and this way we only declare them once. They only create this garbage once. And now we can use these variables down here and put this one in here and put the other one in here, change this to player 2. And this does the very same without declaring new strings each update, each frame. One more thing about code optimizations, and this is not really an optimization of the code itself, but of the readability of the code. Remember, in the ball script, we had this complicated adjust angle method, and we used some comments there to explain what's actually going on. I want you to go through the code and see if there are other places where you think, oh, this might be complicated. I'll probably forget about what this does in the future, and write comments explaining what's going on. Your future self in a month or in a year that opens this code again will thank you a lot for this, and also other team members that read your code. One more thing I want to add to the game is a little quit button, because in a Windows build, and we are offering a Windows build to our players, it's always awkward to have to press Alt F4, and this is something that is done quite quickly and also lets us learn something new. So let's first add this button to our menu, and for this I'm just gonna duplicate Control D, the play mode button, move it down a little bit, maybe all the way to the bottom. Yeah, maybe to 432, something like that. Rename this one to quit button. We still want to stay tidy and clean, and give it another text. Let's just call it quit. And now this volume slider is positioned a bit awkwardly, so let's move that one up a tiny bit, maybe to 300. Alright, yeah, this looks good enough. So far we are handling all our UI stuff and logic in our game UI script, and I'm gonna leave it at that for this tutorial because this class is not that huge yet. Yeah, it's not even 100 lines of code, but if your UI code grows, I want you to think about dividing it into several smaller classes. For example, we could have a class that is just for the quit button, or for the play mode button, or for the volume slider. Yeah, each element could have its own class so that it's separated more clearly and you still have the overview. And the code for this is super simple. Let's just go into our game UI class and add a new method. Where do we have? Here's the onSwitch play mode button clicked. So right below it, let's add a method called onQuit button clicked, and we can just call application.quit. So this comes from Unity and we can just use it. So save it, and then back inside the editor, we still have to hook up this button. So we duplicated this play mode button, and now it's doing the same thing when we click it as the play mode button. We don't want it. So let's change what happens on click here, game UI, and on quit button clicked, and that's it. Now this quit button will also show up in our WebGL build at the moment, but clicking it in the WebGL build in the browser will do nothing. It's just gonna be confusing. So let's remove it from the WebGL build. We can use something called conditional compiling to do this, and I'm just gonna paste a method in here, down here maybe. We're gonna call this check disable quit button, and we still gotta create a reference for this quit button. It's enough if it's just the game object because we just want to switch it off. So let's do that here. And also in the start method, we're gonna call this method, check disable quit button. And now we're gonna jump back into it. And this one is gonna set the quit button inactive, set active, false, and it's gonna disappear. But it's only gonna do it if we are on the platform WebGL. And this is the syntax for that. You have to use this hashtag and then if, and then there are some defined symbols to use for this. And at the end, you have to use the hashtag and end if. So this is mostly for platform dependent compilation. So you can distinguish between different platforms here. Let's go back into the editor first and see if it actually works. We have to still assign this reference right here. And now, if we start the game, let's see. Okay, the quit button disappears. This is because we're not in the WebGL build yet, but we have WebGL used as our target platform. So this code also executes. Let's see if it actually works. And for this, we're going to go into the build settings and change our target platform to Windows. So click switch platform, and this is going to take, once again, a few seconds, but it's going to be really quick. It's almost done. It's probably done right now. I should probably thought of something better than this. Oh, okay, and it sometimes opens up Visual Studio again once you switch the platform. So just click that away. It's recompiling the script. So this, you know this from the publishing and upload video. This whole build stuff, it takes some time. So let's test it by clicking build and run. And let's select our folder. And once again, the Windows build, once you did the first one, it's going to be really quick. So I'm not going to cut this because it's going to start any second now. And here we are. It's going to start up right now. Right, so this is our game. We are now in the Windows build and we see the quit button down here. And if we click it, it exits the game. So this is working as expected. A few more words on this conditional compilation thing. I'm going to leave the link to the documentation down in the description. And yeah, we can distinguish between a lot of platforms here. So we used if Unity WebGL, but we can also check if we're in the Unity editor or not. We can also put an exclamation mark there to negate the expression. And we can check for standalone and all the other platforms. We can even check if we're in a development build. And also what we can do, so these symbols are the ones that go right here, right? And we can even define our own symbols. So for this, we can go to the project settings, to the player settings, and this is under other settings. Come down here, 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 and right here we have scripting defined symbols. We already got one here for the post-processing that we implemented. This was added by the package automatically. But we can, for example, one example for this is making a debug build where you have some cheats inside the game that you only want to trigger if this scripting defined, these things are called scripting defines, is set. And in this way you can probably distinguish between a debug build and a normal build. But as we saw, like in the documentation, we can also check if there's a development build. So yeah, this is probably it about conditional compilation and scripting defines. It's really powerful, but probably not much of a beginner's topic, but I just wanted to show you this because it's gonna get important for you if you want to build for different platforms. And that's actually what we're doing already. Like, it's just a small use case with this quit button, but there can be a lot more. And now you know about this stuff. I also promised quite some time ago to speak a bit more about software architecture. This is mainly a concern when you have like multiple scenes in your game or want to restart scenes or you need a loading scene. It's not a problem in our case, but it could become one if we extend our game. So we have our game manager class, which is a singleton. So it offers an instance and it's just one instance of the game manager is there at any time. This is what this does. If there's already an instance, then we destroy the new one. Let's try and see what happens if we reload our scene and if the game manager can take it and our game can take it. And for this, we're gonna use another namespace. So scene management is in a different namespace, not in Unity engine. And to use that, we're gonna use this using define. Okay, I use the word use a lot, but let's go on. Scene management, using Unity engine scene management. And let's scroll down a little bit. And where could we call this? Maybe once we check the win, right? So we have the game end right here. So let's load our scene let's again load our current scene. And for this, we're gonna call scene manager load scene, and we're gonna get the active scene, which is our only scene actually, and get its name. So this is the syntax to just reload the current scene. Let's test this out and see if it reloads the scene. So I already started the game and I set the volume to a lower value. And right now the game ends and the scene manager load scene code is called. And you probably heard that the music starts again, and we can also see it. If we didn't reload the scene, there would be a win screen up here. But so far, so good. There's one problem. We are not saving the volume. We're just setting the audio listener volume. And this is a global thing. But we're not like checking the audio listener volume yet at the beginning of the game. So actually this slider should be at like 30% now. If I change this now, you will see a sudden bump in volume, right? Okay. And we can set it down again like it was before, but this does, like, the value on the slider does not persist between the scenes because we would have to set it to the audio listener value, but the audio listener value is a global thing and it persists through scene reloads. And let's see if everything else is also still working. So we got no errors on the console and this game looks good, so I think it's still working fine. So far so good, but if the game grows and gets like multiple scenes, for example, you want to have common functionalities like input or maybe your UI, your in-game menu. You want to have this available to you in every scene. So you gotta have some persistence in there. You don't want to create this in every scene anew. Like, you could make this game manager a prefab and put it into every single scene. That's one approach to do it. But there are other approaches, and we're going to try one other approach out now, and that is to call don't destroy on load on the game manager, which will persist the game manager across reloads. Let's try this out. And right after the start of the game, you can see that the game manager disappeared from this main Pong scene, and there's a new scene called Don't Destroy on Load where our game manager now is. So everything under there will persist across scene changes. So let's start the game, and yeah, I'm gonna just lose real quickly here and see what happens. Okay, so the scene gets reloaded, but we get this error right here saying missing reference exception. And indeed, if we look into the inspector for our game manager, we see there's no more reference to the UI, to the screen shake, or to the ball. And if we open this scene, yeah, this is the Pong scene. Only this scene got reloaded. And it has like the UI inside it and the ball inside it, but the game manager persisted. So the game manager had a reference to all these objects before the scene got reloaded at the very start of the game. But once the scene is reloaded, the game manager is still there, but it's still looking in the previous scene before the reload. But now we got a new ball, a new UI object. This is a problem, and there are multiple possible solutions for this. One solution would be that we could go into the ball script, and in the start method of the ball, we could have the ball register itself to the game manager like this. So we just get the game manager instance ball and set it to this ball. So this is the new ball. We could also make the objects where we want the references to persist. We could just make them children of the game manager, and all the children of the game manager, they persist with the game manager, and it also keeps the references. This is probably cool for the UI to do, so just make the UI a child of the game manager. This is something we can do, and this is something I actually sometimes like doing. But for the ball, this feels really awkward, because then we could make the case, hey, we could make all the level objects children of the game manager and everything persists. And if everything persists, then it's pretty much the same as if nothing persisted. So you see, this is a pretty big problem and a pretty big field, and concerns the overall architecture of your project and code. There are many possible approaches, and it is a bit beyond the scope of this tutorial series to go too much into detail on this. I just wanted to prepare you a bit for the challenges ahead of you when dealing with bigger projects, and I want you to be careful with this don't destroy on load. We had it on the game manager right here. Try to only use it for things that are not really part of the scene, but more of an overarching thing, and always keep the references in mind. For now, let's just remove all of this code that we just tried out again, as we don't need it for our one scene game. And there's also in the ball this one. We don't need this. We can leave it there, but I'll just remove it again. So you can get very far and make truly awesome games that have just one scene. So if this all seemed a little bit overwhelming, and I can imagine it does, it's still sometimes overwhelming for me after all these years. Don't worry too much. You don't really have to deal with it yet. I just wanted to let you know about stuff. So maybe as a little takeaway of this whole section, only use don't destroy on load on objects that have no references outside of themselves and their children. And in special cases, maybe, you can have objects, scene objects, make them register themselves to your persistent classes. I want to briefly talk a bit about testing. When you develop a game, it is very important to test your game thoroughly. And there are different kinds of tests that you can do. So one kind of test is the so-called play test. And this is something that you can't really do on your own, where you need others to play your game and probably watch them and see if they understand the game, if they enjoy the game, if the game works for them. And it doesn't have to be the whole game. It could also just be one game mechanic, and this testing is there to validate that your game is going in the right direction. And of course, you want to test your game for errors, so-called bugs. And these come in different severities. There are those where your game just crashes. There are those that are called plot stoppers, where it's not possible for the player to continue the game because of whatever. Maybe something in the logic goes wrong and like a quest giver suddenly disappears or something like that. And then there are those of a lower severity and also of a lower priority to fix. Like you want to fix these crashes and plot stoppers with the highest priority. Yeah. And after that, you can go to like smaller bugs that are probably like visual glitches. Something doesn't look right. You have to fix this. Some objects suddenly pop up or disappear, or there's like some physics problems where you can't jump on a platform, but it still allows you to like finish the game. And yeah, you really gotta prioritize how you tackle these bugs, in which order. This is what I want to tell you about. And you can test these bugs for yourself. So you can just play the game yourself and find these bugs. But be careful with that, and also let other players test for bugs. Because after a while of testing your game yourself, you develop a certain blindness towards it. You don't see some things as clear as others see it. And you also develop some patterns on how you play the game. And it is highly valuable to let others play the game to find stuff that doesn't work. So of course we tested our game again and again during the series, and I'm a bit hopeful that we found everything that is more severe and of a higher priority. But if I know one thing from years of game development, it's that there are always bugs left. And that's fine. If they are of a lower priority or they're just visible to you maybe, then still release your game. That's okay. If there's nothing game breaking in it or nothing of a higher severity, go for it. Like, it's time that goes into fixing even these small bugs, and you really gotta decide what is more valuable, your time or fixing these tiny bugs. That said, if you find any bugs or found any bugs, please let me know in the comments, and then we can tackle those together. One last thing for today. Remember, we had some issues with the WebGL build and especially the resolution for the game, and I looked into this a bit more and found something quite nice. This is a WebGL template that we can download and use in our game, and it's gonna solve all these resolution problems that we had for us. Isn't it magic? We just have to download it right here. No thanks, just take me to the downloads. You can of course give a donation, definitely, they deserve it. And yeah, I'm gonna choose the latest one, download it right here, and then I'm gonna extract it. This is on my other monitor, and we are just gonna go back into Unity and the extracted folder, and it's gonna be the WebGL templates folder, not the subfolder. Drag this whole folder under your assets. So it's gonna be directly in the, you could call this the root of your assets folder. And then inside the project settings, if we go to the WebGL tab, resolution and presentation, then we have this better minimal template that we can choose. And now we're gonna upload our builds again to itch.io, and since we're still on the Windows platform, let's build this one first. Build and run. Yeah, we just built it, but we're gonna build like the final version now. And I hit build and run to really quickly make a little check if it's working. So the sound is working and the AI is also working and the player input is also working. Okay, of course, that's a little flaw with our in-game menu. Like you would expect in a game like this to be able to press ESC and then the menu pops up. We don't have that, but I encourage you to try to add this. So the menu only comes in between rounds, and I think that's okay for such a short and little game like this. So now we have our lovely little quit button right here. And what we can do now is go to the folder where we have our build. And once again, we can zip it, and then we will go to itch.io and upload our file. And of course, it's again in my other game, so I'm just gonna go quickly into the Pong folder and we can upload this Windows build right here. So now let's do the same thing for the WebGL build. I already switched the platform and I already built it once, so it goes quicker this time. So the first build again, because we made so many changes, I guess it took a few minutes, but the consecutive ones are lightning fast. Like it's already done. Yeah. Once again, go into this folder, delete the old zip, select all, zip it, then go to itch.io, upload files, and select your new zip, and we can upload it now. And it still doesn't support this auto detect size, so we still have to manually set the size, but you can set it to something arbitrary, I think, and it's always gonna stretch it so that nothing is cut off. So that's something that's really cool. I'm gonna just set it to 720p, and we can also use the full screen button now. So let's save this one, view the page, and see if everything works. So I think I'm not gonna make a devlog for this tiny update. I'm just gonna run the game and let's see. Also, always check if the sound works. Okay, it's still there, and we got this little full screen button down here now, which actually works, which is great. So this is our new WebGL build that we can play in full screen now. Super cool. There are many awesome extensions and plugins for Unity like this one, and we'll talk a little bit about this in the next part of the series, which will also be the grand finale. I'll also give a bit of an outlook, how you could develop this little game further, just give you some ideas, and also some final tips for your own journey in game development. That's it for today and this video. I hope you enjoyed it and you're enjoying the series overall. Let me know your thoughts, feedback and questions down in the comments. I wish you a great rest of the day and I hope to see you here again soon. Bye!